Bismillahirrahmanirrahim. So this is the 7th lecture of the statistics and probability theory. Review of the previous lecture. Up till now we have discussed the quantiles, which is the part of measure of central tendency, and in quantiles we have discussed how to calculate quartiles, deciles and percentiles. In quartile, we divide the data into 4 equal parts. In deciles, we divide the data into 10 equal parts. And in percentiles, we divide data into 100 equal parts. In previous lecture, we have learned how to calculate quartiles, deciles, and percentiles for the group and ungrouped data. But up till now, we have discussed that statistics is an art or science used for the collection, presentation, analysis, and interpretation of numerical data. We already know what is the method of collection of data. Those are primary and secondary. How to represent the data. Now we are in the analysis phase, and in the analysis up till now we have discussed the measure of central tendency, which means that how to calculate a single value which represents the whole data set. That means your single value which you have calculated is representing your whole data. Today's topic is measure of dispersion. This is also the part of the analysis of data. So now what is the measure of dispersion actually is? Measure of dispersion. So what is the measure of dispersion? Scatteredness of data from central value is known as dispersion. Up till now, we have learned that what is measure of central tendency. Measure of central tendency means a single value which represents the whole data set. And but you can have same mean or measure of central tendency of two different data sets. This could be possible. So what will we do? How could we find out the main features of the data sets as they are representing the same mean but have different data values? So in this case, we discussed the measure of dispersion, that how much the data is dispersed around the central value. That central value could be the mean. If you say that, then how much the data is dispersed around the mean. Dispersion is basically means the scatterness. So how much the data is scattered around the mean. Now here we have number of observations, and this is the 3 data sets which representing the different colors, and you can see this is one type. This blue one is the second one, and this purple one is the third one. Now if you say that this is the symmetric data, as we have the single peak and the data seems to be symmetric, so you can see that this blue one, or you can say that this is some sort of aqua color, this is the flat one, and this blue one is the moderate one, and this purple one has the highest peak. But this one is the narrow than the other two. So if you see this, that this purple one has all of these 3 data sets have same mean, as this is the central value. So all of these 3 data sets have same mean, but they have different dispersion. Why? Because this one is more flattered, this one has a little bit higher peak than this one, and this purple one has the most highest peak. It means that most of the observations are here, but in the case of this one, observations are expected to lie on the tails. So this one has the higher dispersion. It means that values are values means the number of observations of the data sets are far away from the central value of the data, and this means that they are moderately distanced, and in this one means they are very close to the central value of the data. It means that this one has the higher dispersion, this one has the medium dispersion, and this purple one has the smallest dispersion, as most of the values are gathered around the central value of the data, and we don't have much values at the tails, as you can see from here. And in the case of this, we have the values near the mean as well as some values near some values at the tail also. But in the case of this flattered one, the values are far distant from the mean, as you can see from the diagram. So measure of dispersion is basically the degree of scatteredness of the data from the central value of the data. That central value could be mean or whatever the central tendency you are calculating. There are two types of measure of dispersion: absolute measure of dispersion and relative measure of dispersion. Absolute measure of dispersion. The measures of dispersion which are expressed in terms of original units of a data are named as or termed as absolute measures of dispersion. Relative measure of dispersions are also known as coefficients of dispersion, are obtained as ratios or percentages. These are pure numbers independent of the units of measurement and used to compare two or more sets of data values. Both of them are used to calculate the measure of dispersion, but in the case of absolute measure of dispersion, units are involved in the measurement, whereas in relative measure of dispersion, the measure of dispersion which we calculate through this method are unit free, and these are basically used to compare the two different data sets. As two different data sets could have the different measuring units. For example, if you are taking the height of the students, which could be in the feet or inches, and in the other data set you are taking their marks, so both of them are different and their measuring units are also different. So this is not appropriate to measure the dispersion of two data sets of different units. For this purpose, what we do, we use the relative measure of dispersion, in which we make our measurement unit free. So with the help of this, we can easily compare two or more sets of data values. Measure of dispersion, as we know that there is absolute measure of dispersion and there is relative measure of dispersion. In absolute measure of dispersion, we include range, quartile deviation, mean deviation, variance or standard deviation. We will discuss in the next part what is the difference between variance and standard deviation. You can write it in this way: variance and standard deviation. Whereas in relative measure of dispersion, we have coefficient of variation, coefficient of quartile deviation. Coefficient of variation, basically the relative measure of the variance, or you can say the standard deviation. Coefficient of quartile deviation is the relative measure of quartile deviation. In the quartile deviation, we have units involved in the measurement, whereas in coefficient of quartile deviation, we make the measurement data free. How to calculate the range? Suppose we have ages of student 13, 13, 14, 14, 14, 15, and we have this data set. So how to calculate the range? We usually select the highest value and the lowest value. The highest value in the data set is 16 and lowest value is 13. So 16 minus 13, the range is equal to 3. This is basically the range of the data set. This is the most easiest measure of dispersion. Easy to calculate, easy to find out without any effort. But the drawback is that we are not including all the values of all the other values of the data besides minimum and maximum value of the data. We are only considering the what is the highest value of the data and what is the lowest value of the data, but we are not including the all other data points. So this is the drawback of the range, but the advantage is that whenever you want to see the quick picture of the dispersion, so this is the most easiest way to find out. And it could happen that sometimes you don't have all values of the data set. You only know some data points of the data sets, including highest and lowest value. So you can find out the range in this way, which could give you some visual picture of the dispersion of the data. So this is basically the range. This start means this is the lowest value, and this end means this is the highest value, and this is the total as you are subtracting the highest value from the lowest value. So this is the range of the data. Quartile deviation and coefficient of quartile deviation. As you can guess from the name that this is quartile deviation, so obviously quartiles will be involved in this, and you know that there are 3 quartiles: Q1, which is first quartile, Q2, which is second quartile, and Q3, which is third quartile. Both group and ungrouped data set, we can find out the quartiles, but quartile deviation can be found out by Q3 minus Q1 divided by 2. If your data set is ungrouped, then this Q1 and Q3 will be found out in the way we have calculated for the ungrouped data. But if your data set is the grouped data, then you should use the formula of group data to calculate Q3 and Q1 and substitute the values here. So this is Q3 and Q1. If you want to know how to find out Q1 and Q3, go back to the lecture in which we have calculated the quartiles for group and ungrouped data. So Q3 minus Q1 divided by 2 is quartile deviation. This is the absolute measure. When I say that this is the absolute measure, it means that units are involved in this. It means that whatever the answer of Q3 minus Q1 divided by 2, the answer will be in the form of units. So if you want to make them unit free, so you will find out coefficient of quartile deviation, which is Q3 minus Q1 divided by Q3 plus Q1. Now this is unit free. No units are involved in this. The answer will be the pure number Q3 minus Q1 divided by Q3 plus Q1. So this is the way to find out quartile deviation and coefficient of quartile deviation. This Q dot D is basically representing the quartile deviation. Mean deviation and coefficient of mean deviation. So M dot D is representing the mean deviation, And the formula to calculate the mean deviation is, this is basically the absolute. Absolute means whenever you use this, you will neglect the negative sign, xi minus x bar. If the negative sign is coming, you will ignore the negative sign and include that number as a positive number. So this is the way to find out the mean deviation for ungrouped data. As you know that whenever the formula for the group data we have seen, frequency are involved in it. Here we have not involved the frequency in the formula. So this is the formula to find out the mean deviation for the ungrouped data. For the group data, we will find out the mean deviation in this way. M dot D, which is representing the mean deviation, 1 over, as there is 1 over n in the ungrouped data, so in the group data this would be 1 over summation F. And summation I is equal to 0 to n, and f of I, which is obviously the frequency, absolute value, or you can say mod of xi minus x bar. So this is the formula for the group data, and this one is for the ungrouped data. And the coefficient of mean deviation, as this is the absolute measure of deviation and units are involved in this, so the relative measure of dispersion, this one is absolute measure of dispersion, and the relative measure of dispersion is mean deviation, which can be calculated from this formula or this formula according to the situation of the data, either it is grouped or ungrouped. So mean deviation over mean, which could be x bar into 100. This is the way to find out the coefficient of mean deviation, which is the relative measure of dispersion. It means that this is the pure number and units are not involved in this. Suppose we have marks of 9 students, 32, 36, 37. So these are the marks of the 9 students, and this is basically the summation x, and we can find out the x bar from here, which is x bar is equal to summation x over n. As this is the ungrouped data, you can see that frequency is not involved in the table. So this would be summation x is 360, as it is calculated in the table, 360 divided by 9, and this would be 40. So this is the arithmetic mean of the data. So we can now find out the mean deviation. How can we find out x? For this purpose, we have to know the formula for the ungrouped data, which is equal to 1 over n summation xi minus x bar. So x is 32, 32 minus 40 is minus 8, and when you apply the mod here, it would be 8. 36 minus 40 is equal to minus 4, and by the absolute value this would be 4. 36 minus 40, again it is minus 4, and the absolute value is 4. And 37 minus 40 is minus 3, and the absolute value is 3. So what you should So what you should know, you know what is the n, which is 9, which is the number of observations, and summation xi minus x bar, and we are using the mod of these values which can be calculated from this column, and the sum of this column is 40. So we will substitute it here. So this would be 40 divided by 9, and this will be 4.44. So this is the mean deviation, and as you can see that we can find out the coefficient of mean deviation, which is mean deviation over mean into 100, and coefficient of mean deviation can be find out mean deviation over mean deviation is 4.44 divided by mean, as you have used the x bar, which is 40, which is 11.11. So this is the coefficient of mean deviation. The mean deviation is the absolute measure of dispersion, and the coefficient of mean deviation is the relative measure of dispersion. So this is the way to find out the mean deviation and coefficient of mean deviation. Now, for the group data, as you can see that this is the discrete group data, as we don't have the classes here. So this is the discrete data set, and this is the frequency. Now for the purpose to find out the mean deviation, this is the formula. As you can see from the here, this is the formula to find out mean deviation. So you need to know the summation f, which you can have by summing up this f column, and this sum would be 245, and you have to know the f of x, as you should know the x bar. So f of x is 0 into 14 is equal to 0. 1 into 21 is equal to 21. 2 into 25 is equal to 50. By summing up this column, you will get 922 divided by 245, which is 3.76. So this is basically the mean of this data set. Now what you should know, you have to find out the summation f into the absolute value of x minus x bar. So what you will do, you will calculate the column of f into mod of x minus x bar. So f is 14, x is 0, and x bar is 3.76. So this is the value 52.68. 1 minus 3.76 into 21, which is 57.96. By summing over this column, you will get 375.4. And what we will do next, we will substitute this value in the formula of the mean deviation for the group data, which is summation f into mod of x minus x bar divided by summation f. And this is 375.4 divided by 245, and the mean deviation would be equal to 1.532. So this is the absolute measure of dispersion. And what is the coefficient of mean deviation? This is mean deviation over x bar into 100, and mean deviation is 1.532, and x bar is 3.76 into 100, which is 40.75, which is the relative measure of dispersion. So what we have learned in this lecture, we come to know that what is measure of dispersion, what are the types of measure of dispersion. As you can see from this slide, absolute measure of dispersion, relative measure of dispersion, we are now able to find out the range, quartile deviation and mean deviation. Similarly, coefficient of quartile deviation and coefficient of mean deviation. Now you can calculate all these values, and we come to know that how to apply the formula for mean deviation and coefficient of mean deviation.